And welcome everybody to the Daily Space Weather. Congratulations on realizing our channel exists. Today we'll be talking about magnetic battles, filaments at the limbs, a Terminator event unfolding. First thing we'll do is look at the sun and ionized helium here. Filaments all around the northern limbs. There's also a large filament down here that may be a little bit more difficult to see. We'll draw a box around that area. Right in there. There's a large filament there also. We'll show you that on hydrogen alpha imagery toward the end of the video. And we'll zoom in a little bit here as the north has quite a bit of activity kicking off. Some great filaments there on the closest star. Here's 193 angstroms. This is ionized iron. And this wavelength is good at showing coronal holes. And there's some activity going on in this area, which is not evident by looking at any of these wavelengths. You got to look at a magnetogram. There's a magnetic battle going on between coronal holes of the north and south orientation. Why? Probably a massive buildup of intercalate gases. And we'll talk more about intercalate gases in today's cosmology segment. Make sure you tune into that. It's one of our playlists at youtube.com/smAshomash/playlists. We also did see a small umbra emerge right up here. And it probably will not be visible long enough to be a named sunspot, but a little bit of activity during this very low phase of activity. As we watch the ramp up of solar cycle 25. Here's a diagram of the solar system. Many of our viewers are interested in astrography, where things are located. Geography, but for space. We'll advance it 1 week. There's where things will be on August 7th. And it looks like August 8th will be the new moon. If you're up before dawn, you might see Jupiter and Saturn up on the ecliptic as they dominate the night skies. Also the moon near the apex of its travels across our sky, and it's getting light here in Lehigh Valley, Pennsylvania. I like to use in-the-sky.org. This is their all sky charts. If you're wondering, put in your location to build your own. This yellow line is the ecliptic, the path the sun will take across the sky. The 10.7 centimeter radio flux, the most proportional solar activity monitor besides sunspot number, is down to 76. Here's the 1 year chart of that. You see these little spikes here. Sunspot number down to 0 here for a couple of days. And all of the grand solar minimum alarmists are probably celebrating the fact that they think that they're right about things like grand solar minima. More on that later. There is a period of geomagnetic unrest forecasted early tomorrow morning. You can see here a KP of 4 forecasted by NOAA. I don't think that's the coronal mass ejection strike, but that's about when we would expect coronal mass ejection strikes to arrive. So, frankly, I just don't know what the forecast is supposed to be for. It looks like possible transient influence coupled with a weak coronal hole high-speed stream. So that's NOAA's forecast. I won't agree nor disagree. I'll just show the data. And let's move into the realm of seismicity. Earthquakes. And so a couple of days ago, we saw a long magnitude 7 earthquake drought end with a magnitude 8.2 south of the Alaskan Peninsula. Let's see what's been going on. The largest earthquake of the past 24 was this 6.1 near Sullana, Peru, located right near a populated area there. Probably did do some damage. This is a location of that 6.1 magnitude earthquake. Let's go to the USGS list. And of course, lots of aftershocks still happening here south of the Alaskan Peninsula. No real surprise there. This one's pretty weird. It's at a very far north location. Arctic Circle earthquakes are fairly rare. We're just scrolling up the list here. Let us know if we miss anything. That 6.1 occurred at 1710 Universal Time yesterday. 1710 yesterday on July 30th. There was a deep quake in Indonesia. It was only a 4.8 magnitude. Tonga and the Easter Island region had simultaneous earthquakes. How about that one? Those both coming in at less than a minute apart. 22:39 and 16 seconds at 5.4 at Tonga. 22:39 and 48 seconds of 5.3 at Easter Island. Right across the Pacific there, but occurring nearly at the exact same time. Like 30 seconds separated those two quakes. There was also a 5.0 at depth at Japan. 5.0 magnitude, 168.8 kilometers depth, continuing on up. Vanuatu recently saw a deep 5.0 magnitude quake as well. And volcanism has actually calmed down, it looks like, according to the volcanodiscovery.com list. Bagana has been erupting, producing a 15,000-foot plume of volcanic ash over the Bougainville Island, part of Papua New Guinea. Also Fuego producing a 16,000-foot ash plume over Guatemala as it explodes. 20,000-foot ash plume over Ecuador from Sangay's explosive activity. Sabancaya exploding, producing a 24,000-foot ash plume or flight level 240 over Peru. And Nevados de Chilean were unable to detect. And while we're unable to detect whether or not it's erupting, don't take that as a cue to pole vault the caldera. We prefer for our viewers to do smart things, and pole vaulting the caldera is not on the list of smart things as far as we are concerned here at smAsho.com. Visit our website, visit our links, check out our merch, etc. Click like, subscribe, share, tell your friends and foes about the channel. Congratulations on finding it once again. Next, looking at the sun-facing suite of instruments on the GOES 16, we see no solar flares here of significance over the past 3 days. No spikes in the proton flux either. No coronal mass ejections have struck for a while. We would have probably forecasted it, as I believe we're the only people in the world to forecast coronal mass ejections before they leave the solar corona. Here's the GOES magnetometer over the past 3 days, and it's looking a little bit spiky here. And it has to do with the Terminator event that we're talking about. There's a coronal hole battle going on the eastern limb of the sun, and we'll show you that momentarily. First, the top view ecliptic plane field plot showing us heliospheric current sheet polarity. So you can see there actually is a tug of war still going on here. The Earth is, this data not even showing a potential field surface source line. Where's the Earth? The Earth is in a zone of non-magnetism, folks. I'm just kidding. It really isn't. These are the definitive polarities of the heliospheric current sheet as polarized by one solar pole or the other. So Earth is probably already in a North Pole-oriented current sheet. This data is nearly 5 hours old. So chances are the Earth is already snapped into this North Pole-oriented current sheet. This data is derived from 51 ground-based magnetometers, as well as magnetometers on stereo A and B, Lagrangian 0.5 and 4 respectively. And you're going to see this blue line here waving all around. That is the indecision of the polarity of the current sheet. And this is a great three-dimensional view. We even featured this as part of our thumbnail on yesterday's Daily Space Weather video. The line of sight ecliptic plane field plot. Also the solar magnetogram on there. And here's the line of sight coronal hole plot. And I would note this area over here, the eastern portion of the Earth-facing solar disk. We've got coronal holes of both polarity. So you can see these red ones coming from down here, stretching up toward the equator, these green ones stretching down toward the solar equator. It's north and south pole-oriented coronal holes in essentially the same place. So essentially we've got some, like I said, indecisive magnetism. It's a magnetic battle. And this is the kind of thing we would expect to see from a Terminator event when the sun goes into a hyperactive state following a hypoactive state. And keep in mind this data also 4 hours and 55 minutes old when we recorded the video. So pretty not well-defined coronal holes here at the moment. We'll be keeping an eye on it. And when I say eye on, well, the pun is intentional. Likelihood of solar flares quite low. Again, we did see some umbrae form, at least one umbra form right up here. We'll show you that at the end of the video in high res to see if it's still there. Probably will not get named a sunspot, though. KP index, a measurement of global geomagnetism, is currently only at a KP of 2. KP2. Geomagnetic chillin' conditions. Let's take a look at the solar wind over the past 24. Fairly uneventful. There was a shift in the phi angle here. That has now reverted. Pretty uneventful here over the past 24. Current solar wind conditions are 6.59 protons per cubic centimeter for the density. Solar wind speed still a bit elevated here at the tail end of a coronal hole wind stream. 454 kilometers per second is the solar wind velocity. Next, magnetohydrodynamic pressure. It's a geospace magnetosphere movie showing 4 hours of space weather modeling framework. It's the product of the space weather modeling framework. And if you want to read about it, just go to the Geospace Magnetosphere Movies page, click on details, and there'll be a link to the space weather modeling framework. You can see the data from which this model is derived. Not a lot of changes to Earth's own magnetic field. We showed you the sun's B field. Here's the Earth's B field, at least in terms of geospace delta B. That means changes in the Earth's B field. And for you new viewers, whenever you see delta in science, it means change in. This one's not in nanopascals, though. This one is in nanotesla. Ground magnetic perturbations, not a lot of them over the past 4 hours. Again, congratulations on realizing that our channel exists. Don't forget to tell your friends and foes about us, as the algorithms don't seem to do it for us. And don't forget to check our playlists as well, youtube.com/smashamash/playlists. All kinds of material there. Not regularly covered in daily space weather videos. We're also on Twitch, twitch.tv/smashamash. We'll actually be streaming our cosmology segment and meteorology segments live to Twitch today. So check those out if you like. Again, twitch.tv/smashamash. We're also on BitChute, and thanks to all of our subscribers over there. Look how many views we're getting. 2,000 views from our 3-day-old video about scary, scary hot planet that will kill us soon. That is also on YouTube, by the way, where most of our content is. And if you're watching any place besides on YouTube, go subscribe over on YouTube. You're missing like 80% of our videos. And we just did today's cosmology segment. This will premiere a little bit later than our daily space weather video. If you've got some downtime, go check out our meteorology segment. Let's get back to space weather. Some charging hazards here caused by high levels of electron flux, probably in those areas around Mexico and the north central Pacific region. Some minor surface charging hazards there. Here's the 1-year chart from solon.info on the relativistic electrons surrounding planet Earth. And those are measured by a geosynchronous satellite called the GOES-16. And the measurement is done around 300 kilometers of altitude, where the F ionosphere is located. The F layer of the ionosphere. So here is the 3-day chart of the electron density for that region. You're looking at literally electron density here. And we almost reach 1,000 pulse flux units, which coincides with 1,000 particles per negative second squared centimeters. And we may actually see slight warning levels today. I'm not sure what the forecast is. Let's take a look. And the NOAA forecast is for slightly higher levels. I would expect us to see warning levels of electron flux here, maybe some additional charging hazards, maybe some communications breakdowns, nothing too major. Here is a diagram of Earth's Van Allen belts. Feel free to pause the video on that. Here's the electron density in sort of a visualization format. The total electron content showing you the electron content for the entire air column. And after this, we'll show you just the F ionosphere layer and vibrational frequency. This is, once again, this is literally electron density. And everything looking pretty normal here, fairly well organized. Van Allen belts apparently, at least according to where the electrons are currently located. Next, the F ionosphere layer, located at 300 kilometers of altitude, one slice of Earth's atmosphere, the bridge between space and Earth in vibrational frequency. And we're seeing anomalies west of South America continuing. And you can see that area just south of the Central Pacific Ocean there, right around here, getting surprisingly high highly vibrational blobs there. So a little bit anomalous once again in the ionosphere. Let's bring up the latest image. That's from 10:15 Universal Time. Things looking a little more normal there. A little bit high vibration on the nighttime side. We'd expect to see some red blobs there. Besides that, nothing too crazy going on in the ionosphere. Next, I'd like to thank our patrons, the true source of funding for the content. Thanks, patrons. You're increasing the probability that these videos will continue to exist, be free for all to view, and publicly visible. Patreon.com/smAsho if you'd like to help us out. As YouTube does very little to help us out, we're pretty sure the algorithms have the thumb on the scale. Thanks again, patrons. Also, again, we did a meteorology segment. Check that out if you're waiting for our cosmology segment to premiere. And here are bonus segments for our daily space weather video. I would note the massive filament down here. This is the Hydrogen Alpha ground-based solar observatory at Lurmonth, Australia. Massive filament down there. That does increase the likelihood of a coronal mass ejection a little bit. We're not putting out an official watch today, but there is always some chance of a coronal mass ejection. We've been 100% accurate in our forecasting for the last several months, if you're wondering. Pretty sure nobody else is doing that or able to do it. And it's probably because I understand the physics. Just saying. Here's the GO16 SUVI thematic map showing you all the features. And you can see this massive prominence up here in the northwest. Next, we're going to show you this area right here. You can see a small umbra there. And it probably hasn't been visible long enough to actually be named a sunspot. Let's refresh these latest images. There's the colorized magnetogram, and we'll take another look at that area. There's the magnetogram. And indeed, there still is an umbra there. In fact, there might even be two now. So a little bit of a complexification of that region. Slightly increasing the likelihood of solar flares coming from the northwestern limb of the closest star. And we'll close things out in my favorite wavelength from the SDO 171 angstroms. It's one of the ionized spectral states of iron. Iron emits ultraviolet radiation when it's heated up to a certain point, and it gives us an idea as to how ionized it is. 171 angstroms is a very specific band of the ultraviolet light spectrum. So let's zoom in on this and close out the video. Thanks again for tuning in, folks. Once again, congratulations on realizing our channel exists. And may that solar wind be at your back.